In the previous lecture, we have seen trace of matrix. In this lecture, we are going to see the properties of trace of matrix. There are four types of properties. In that, first one is trace of A plus or minus B is equal to trace of A plus or minus trace of B. Suppose A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 7, 8. Coming to the right side of the property, trace of A plus or minus B, that is A plus B or A minus B, anyone you can take. A plus B is equal to 1 plus 4, 5, 2 plus 5, 7, 3 plus 7, 10, 4 plus 8, 12. Now trace of A plus B is equal to 5 plus 12. These are the diagonal elements of A plus B matrix 5 and 12, that is equal to 17. Coming to the right side of the property, trace of A means A matrix trace, that is 1 plus 4, that is equal to 1 plus 4, that is 5. Similarly, trace of B is equal to 4 plus 8, that is equal to 12. Now trace of A plus trace of B is equal to 5 plus 12, that is equal to 17. From this you can observe that trace of A plus trace of B is 17 and trace of A plus B is also 17. Therefore, trace of A plus B is equal to trace of A plus trace of B. Trace of A minus B is equal to trace of A minus B. Trace of A minus B is equal to trace of A minus trace of B is the homework. Coming to the second property, trace of A is equal to trace of A transpose. You can see here trace of A is equal to 5. Now A transpose is equal to, by interchanging the rows and columns of A matrix, you can get the A transpose matrix, that is equal to 1, 3, 2, 4. Now trace of A transpose is equal to 1 plus 4. These 1 and 4 elements are the transpose matrix diagonal elements. You can see from here, that is equal to 5. You can see from here trace of A transpose and trace of A both are equal, therefore trace of A is equal to trace of A transpose. Coming to the third property, trace of K into A is equal to K into trace of A. Suppose matrix A is multiplied with 2, 1, 2, 3, 4, K into A is equal to, that is equal to 2, 4, 6, 8. Now trace of Ka is equal to 2 plus 8. These are the diagonal elements of Ka, that is equal to 10. Coming to the right side of the matrix, K is equal to 2 here. Trace of A is equal to 5, as we already discussed over here. Now K into trace of A is equal to 2 into 5, that is 10. You can see from here and here both the trace of matrix are same, therefore trace of K into A is equal to K into trace of A. Property is verified. Coming to the fourth property, trace of AB is equal to trace of BA. You can take 3 matrices also, but for easy understanding I am taking here 2 matrices. A into B is equal to 1, 2, 3, 4 and 4, 5, 7, 8. The the matrix multiplication, we will get one row and one column, that is equal to 4 plus 14, 5 plus 16, 12 plus 28, 15 plus 32, that is equal to 18, 21, 40, 47. Now trace of A into B is equal to 18 plus 47, that is equal to 65. Now coming to the right side of the property, B into A is equal to 4, 5, 7, 8 and 1, 2, 3, 4, that is equal to 1 row into 1 column. 4 plus 15, 8 plus 20, 7 plus 24, 14 plus 32, that is equal to 19, 28, 31, 46. Now trace of BA is equal to 19 plus 46, that is equal to 65. So as you can see from here, trace of AB is equal to trace of BA. The property is verified. In the coming presentation, we are going to see the upper triangular matrix and lower triangular matrix. Thank you for watching. See you in the next lecture.